When we are given x values, there are strategies for being able to predict the y value. First, it's extremely important that you avoid making predictions that are outside the range of data values. When you don't have this kind of information, you are extrapolating, and your data is not reliable. First, you want to be able to think of creating residuals plots that will help you determine linear correlation and see if that exists. We'll be doing that later. Additionally, if you know linear correlation exists, we can find our least squares regression line. And what that does is it will take our data and find a line that will help us to best fit that data into a straight line to help us get a better understanding of predicting values for y when we know an x value that falls within a data range. To do this, we can then substitute a value for x into that regression equation and approximate or predict the value for y. However, if we know that a linear correlation does not exist, it doesn't really matter what the value for x is. The best predicted value for y is going to be the mean or the average of all of the y values. So first, let's look at some definitions. Well, what is a residual plot? Well, this is a type of scatter plot that is used to help determine or confirm if a linear relationship exists. What we're actually looking for when we look at this residual plot is no noticeable pattern, meaning that the points are going to be kind of scattered all over the place. This actually will indicate a linear relationship because the residual plot is when we are graphing the x values and the difference between the y value and the predicted value. The little y hat is actually what we call the predicted value, which actually brings us to what is a residual. Y minus y hat, that coordinate, the difference between two values. The first value of y is the observed value, and the little y hat is a predicted value. A residual is just the difference between an actual observed data point and the value that is predicted by a regression model. A positive residual means the actual value is higher than the prediction, while a negative residual, the actual value is lower than the prediction. The least squares regression line. This looks like b hat equals b sub 0 plus b sub 1 times x. B hat is still our predicted value. B sub 0 is our y-intercept. And b sub 1 is our slope or our rate of change. Since our least squares regression line comes from a sample, b sub 0 and b sub 1 are also values from a sample. A correlation coefficient. This is represented by little lowercase r. It also comes from the sample of data that we are using. It measures the strength and direction of the linear correlation. Your value for r can be any number between -1 and +1 inclusive. As the value gets closer to -1, you become a strong negative correlation. And as the value gets closer to +1, you become a strong positive correlation. Your coefficient of determination. This is the value r squared. This measures how well that least squares regression line fits the data. The closer this value is to 1, the closer our predictions are to the actual values on average. Finally, we have a lot of variables floating around, so we need some rounding rules. First, when we are writing our least squares regression line, we are going to be having values for a and b. We're going to round these to 4 decimals. Above our least squares regression line uses b sub 0 and b sub 1. On our calculator, these are going to be replaced with the values a and b. Next, we have our correlation coefficient and coefficient of determinations r and r squared. These will always be rounded to 3 decimals unless otherwise stated. And finally, we have our predicted value y hat. Whatever form our original data is in, this is how we are going to round our predicted value as well.